15 húzok, szívesen veszek egy is beszálltam, csak hogy én nem látom nagyon itt a hiányvonatokat. Jó, rendben, oké. Még nem aludjál. Még egy kicsit ránézek. Bőven, úgyhogy ez is jól sikerült ez a része is.
No, I was doing something out first.
Okay. So, this guy who can help us.
Okay, excellent.
Can I give you something to drink?
No, I'm fine, thank you. Right.
Not just beer. We have other drinks as well.
Right, what am I doing? That. Oh no.
Can I double the up for you?
Yeah, sure, go for it. So.
Alright. I know the plus from. Okay. So I'll just need a new tab. This will be my problem.
I'm getting paranoid and
Are you presenting from internet or from local?
from local.
Okay.
Okay, that's good.
Okay. You have to connect to an Wi-Fi hotspot
Okay.
for auditorium. Type in password. I need password. There is no internet on this hotspot, but you can present here.
Ah,
Press in.
Dolgoztam a pénzügyi szektorban, van egy vezető és kereskedelme, vagy családom
Now you can connect.
okay. So that.
From the name up there.
Okay. Now, could I share window? That might be.
You can share on the window if you want.
Okay, so I'm going to try. Let's just try.
You can close it.
So let's just try that.
Something.
Ah, water. Great, thank you. Oh, this is good.
beer or a singleton.
Good suggestion. So actually, that one. Yes, go on.
Just click on the button. You can do that.
Yeah. Need to be careful with that.
Of course, yeah.
You can. So I think we can start now. If everything is okay with us.
Just about.
Okay, you have time because I don't want to spend too much time here. Because
Okay, so I've got enough time to get a slice of pizza while you're talking.
Yes.
Okay,
Yes.
so when you stop speaking Hungarian, I will know that I need to be speaking.
No, I'm going to speak in English, so you cannot know that. So, yeah, so I don't want to spend too much time here because I rather want Kevin to spend time here on the stage. I just wanted to give you first of all, sorry, thanks for MRCs for hosting us. So who hosting, like we have everything actually and we need. I wanted to give a heads up, but actually I'm not sharing screen anymore, but I can give you some extra discount for DDD EU conference in Amsterdam in January, happening in Amsterdam January. So if you are interested in that, just contact me, let me know. Other things, actually, I don't really have anything to share. Maybe you can pencil a date in your calendar if you want to have it in there for the next meetup, which is 8th of January. Another presenter will come and present to us, but I don't want to say it for sure because I'm not yet sure 100%, but it will happen hopefully. So 8th of January. And I think I let Kevin just talk about those trees and systems.
Yeah, okay.
So, welcome.
Yes,
Thanks.
thank you very much. Okay, right. So, I'm going to talk about a system is not a tree. So I'm Kevin Henny, which is a conveniently internet unique name. And I have a number of interests, one of which is photography. So this photograph is made a short list recently. There are, apart from black and white, there are no effects applied. I live in Bristol in the UK, and this is what it looks like. This is summer in Brexit Britain. Actually, it's the beginning of January last year. It's quite dramatic. However, I thought, this is not really an excuse for me to mess about with photographs, but given the title, "System is not a tree," I thought, well, let's just show some trees. But in software, the trees are upside down. Okay? The trees are upside down. The root is always at the top. Okay? The leaves are always at the bottom. Whether you're drawing a system of classification, whether you're talking about folders, whether you're drawing organizational structures, any of these things, we know that trees have the root at the top, and it's the real world that has it wrong. Okay? They have the leaves at the top. Okay. In the real world, the trees are green. Code doesn't necessarily have colours, but if we have anything, we have red-black trees, and we've got other trees like that. Trees are also the subject of, they occur so often, XKCD. It's a Christmas tree with a heap of presents underneath. We're not inviting you home next year. There you go, that's my contribution to Christmas. We recognise that Christmas is coming, okay? But there's a point behind all of this. As I've mentioned, we have these classification trees. We have structural trees, hierarchies. Donald Knuth notes trees sprout up just about everywhere in computer science. So they're very natural. There's a number of reasons we like trees. They are convenient to think about. They are hierarchical. It allows us, there are things that human beings find convenient to think about. Hierarchy and sequence. One thing after another, that works for us. One thing contained within another, that is a hierarchy, okay? one thing branching out to another. That is a hierarchy. We find these convenient thinking models, and it is natural to try and want to organise the world in them. And indeed, now, you might be a little bit surprised. Michael Jackson was not just responsible for some major hits in the 1980s. This is Jackson, the requirements guy. This is Jackson, the guy who came up with a methodology in the 1970s for structured programming, JSP, Jackson Structured Programming. A number of people who are old enough, I'm just looking around the room, a number of people who are old enough, that would be me, may well remember this stuff. And in the 1980s, Jackson, well, I wasn't programming in the 70s, but in the 1980s he did Jackson Structured Design. These are still present concepts when people were talking in the 80s and 90s about how to organize systems. This is a really interesting book. I mean, it's got an incredibly dull title. I mean, honestly, Software Requirements and Specifications. I'm falling asleep already. This is not an exciting book. But you get a sense that there might be more to this in the subtitle. A Lexicon of Practice, Principles and Prejudices. Oh, okay, so he's playing around a bit. The whole book is really a series of essays, about 74, 75 essays that range from half a page to about 3 or 4 pages long. And they are alphabetically ordered. He's messing with us. And it's about software, it's about requirements, it's about domain modeling. This is one of the first books that I properly would reconcile with the concept of domain modeling. And his goal was to try and understand the shape and nature of our problems, as opposed to the shape and nature of the solutions. This is kind of a subtle point. And based on some of the work in here, so this was published in 1995. 2003, he published another book called Problem Frames. Funny enough, the same year as Eric Evans published Domain-Driven Design. And in Problem Frames, he really looks deeply into domains from a very different perspective from Eric's. Eric's is much more anchored in implementation. Jackson is very much interested in shaping and understanding the shape of the problem domain. But anyway, I said this was organized alphabetically. Remember I said we like sequences. The first entry in the book is on arboricide. Arboricide is not a common English word. In fact, I'm not even sure until Michael Jackson put it as the first word in the book, it was actually a word. Arboricide is the murder of trees. So what he's talking about here, says the victims of arboricide are the descriptive tree structures that are so often found in software, holding together many individual elements in one coherent and immediately understandable harmony. We are drawn to the idea of trees, and yet so often we break the trees. That's where we end up with problems. And as he says, software development should not be a trade of constructing difficulty from simplicity. Yeah, I'm looking at you. Okay? This is the problem. We're really good. Somebody gives us something, oh, well, that looks kind of easy. I bet I can make that interesting. I bet I can introduce complexity here, and I can make it future-proof. I can put in, I can use technology. It's quite the contrary. So where there are trees to be shown, you should show them and refrain from turning the relationships they describe into a puzzle. This is a really interesting point. And there's a very interesting, very subtle point here. He's not saying make everything a tree. Where there are trees to be shown, you should show them. Don't make everything a tree. So, we talked about complexity. This is one of the most frequently cited books in the whole of software development, Mythical Man Month. Has anybody actually read it? Excellent. That's actually more than 0. Well done. Now, I read this. So this is the anniversary edition. The book was published in the 1970s. And it refers to Fred Brooks's experience of the System 360, the IBM System 360 project in the 60s. So that's the 70s writing about the 60s. Then the anniversary edition in the 90s, that's this one, included some essays he'd written in the 80s. Now I actually read it in the late 80s, but I was kind of like a poor new programmer. I did not have the money to actually buy it, so I borrowed it off somebody else, and I've never been able to get the original that I wrote. However, the important thing is that this edition contains a couple of extra essays, one of which includes this quote. It's on complexity. Let us examine software's difficulties. Following Aristotle, that well-known programmer from ancient Greece, programming is always older than you thought it was. I divide these difficulties into essence, the difficulties inherent in the nature of software. Put another way, to be specific, the difficulties that are part of trying to express a problem domain in software. You don't really get a choice in these. Okay? The only way to make something to lose essential complexity is to reduce scope. The only way to reduce essential complexity or eliminate essential complexity is to not develop it. Yeah? In other words, the only way not to lose is to not play. And accidents. Accidental complexity. This is where it gets interesting. This is where we have the trade of constructing difficulty from simplicity. Those difficulties that today attend its production but that are not inherent. In other words, all that stuff you call technical debt, all of the confusions, all of the legacy stuff, it's just like, this is not the right schema, but we've got that schema, we can't really change it easily, so we will continue with that schema even though it's not right, and then we will put the workaround in the client code. That's accidental complexity. In other words, that's not necessary. That's nothing to do with the problem of the domain that you are trying to solve. That's something we've created. And here is the question. He asked this question in 1987. How much of what software engineers now do is still devoted to the accidental as opposed to the essential? Yeah, you know what? He could have been writing this in 2018. I still ask this question. How much effort are we expending on dealing with stuff that is not actually the problem being solved? Okay, the problem being solved is, hey, we've got a lot of bad code. No, that's not actually normally what the business wants. The business wants something else. So we are always struggling, and I suspect we will always struggle. But the question is, how much? We have a choice here. And so, through time, we have always tried to simplify things. Now, I need to figure out where I can turn the dial all the way to the code, and I can also turn it all the way down. How many people here touch code? Okay, that's quite a lot of you. Okay, so I'm not going to exclude everybody else, but I'm going to leave that with a slight bias towards that. I thought that might be the case, which is good because that's in the slides. So this is a book that was published in 1972. Structured Programming. Notice the phrase, structured. Okay, the structured programming really started in the late 60s, gained popularity in the 1970s. And what is the goal of structured programming? Well, software development was relatively young back then. And what people discovered is that it did not really have structure. Okay? It was very much kind of like, we're building this and we're making everything up as we go along, and we're using all kinds of stuff. And there's a very powerful idea that was introduced in the 1960s. It didn't make its way into all of the mainstream languages until a bit later, but we got so used to it. One of those powerful mechanisms for program structuring is the block and procedure concept. This is really interesting because what we're saying is that a block of code, it's a sequence of stuff. And what can blocks contain within them? We can describe the actions of a program and we can relate it to the actions of the business. We can write our business logic down, and importantly, we can name these blocks as parts of our business process. So in other words, it's process-oriented, it's action-oriented, it's task-oriented, it's procedure-oriented. But even better is the concept of the block, because you can nest blocks inside of blocks. Cool. Yeah, these days we kind of have curly brackets. Back then it's kind of like begin, end. Okay? But this is the whole thing. We've got a tree structure. Prior to this, that was the invention of the block. We can actually date to 1960. The language was Algol 60. There was an Algol 58, but that was a bit messy. There was Fortran, that still is messy. But the idea is now we've got trees. This is nice. But there's a little problem here. Because somewhere in the trees, there's a mad axeman. We'll get to the mad axeman in a moment. We might date it to 1960. But it turns out, a little bit of digging, and this is absolutely fascinating. I didn't learn this until earlier this year. This dates from 1948. This is a programming language that was not implemented, sadly, until the 1960s, after it could have really influenced things. It's by Konrad Zuse, who's the German inventor of the electromechanical computer. Now, I don't need you to understand this, except to notice that it is everything, with the exception of this, is beautifully nested. It's a tree structure. This is the whole point. It's a hierarchical program structure. It is the language is plan calcul. For those that are interested, this is a sort routine. Ord is short for ordnung. This is a while loop. That's not while, that's Wiederholung, so repeat. These are clauses. This is if, do this, not if that condition, do that. He hadn't invented. The else was not invented. The else was not invented until 1960. But that's fine, because there's an elegant description. Everything nests like Matryoshka does. It's perfect, it's easy to comprehend. As you may notice, this is going to be quite difficult to implement on a standard keyboard. Which is perhaps why it was not immediately implemented. So this is really interesting. This is structured programming in 1948. But there is the issue. There is the small issue of the mad axeman. The mad axeman has a name. The mad axeman is called goto. We have other names for the mad axeman. Break, continue, return. These are all softer versions. But goto is the ultimate weapon. Okay, it is the chainsaw. It's not an axe. I've underestimated it. It's a chainsaw. And this is the problem, because the goto is very close to the machine. And what is the problem with the goto? The problem with the goto is that when you come across this beautiful nested structure, a block structure, and I'm trying to organize my business processes and say there is a relationship between the business process and the block structure. This is what Jackson was originally doing with Jackson structured programming. He was talking about the business, and what elegant as his process was, he actually had the greatest appeal to COBOL programmers. That was what was taught in a lot of schools, was use JSP to tame the goto. Okay? The idea is you're working in a language that doesn't have block structure, but that doesn't mean you can't think in block structure. The idea is that if you reason in terms of trees, if you try and describe your business flow in terms of these nested concepts, this is good. But the goto cuts straight across this. As somebody said, it does serious violence with control flow. And it also disrupts our reasoning. So, 1968, 50 years ago this year, one of the most famous letters ever written in computer science was written. Edgar Dijkstra. Goto statement considered harmful. It goes all the way through, and he talks about the block structure. He says it's absolutely fine at the machine code level, but look, if we're trying to reason at a higher level, if we're trying to look towards the world where we are trying to program to, as opposed to the machine that we are trying to instruct, if our programming languages have this perspective, then this is not the right tool. This is too low level. So this is a really famous letter. It's also, and you may have come across a lot of phrases. You know, this is goto statement considered harmful. You may have come across blogs and talks where somebody goes, something considered harmful. Okay? This was the first, this was the starting point. Okay, this is the point of origin in software. Now, one of the things I'm interested in, so I'm interested in words, I'm interested in language. And I run a page on Facebook called Word Friday. And most Fridays, I will post a word that is perhaps a little unusual with its definition. And one of the words that I posted, I don't know, 5 years ago, 6 years ago, was snowclone. This is a good way. If you can drop it into a conversation, this is great. What is a snow clone? A snow clone is cliched wording. It's like a templated phrase. And it normally has its origin in a single quote. Examples include, X considered harmful. These aren't the X's you're looking for. X is the new Y, it's X, but not as we know it. No X left behind, it's X is all the way down, and all your X are belong to us. Okay? In other words, these are phrases that you probably heard, and you play around with it. So these are parameterizable phrases. Go-to statement considered harmful is one of those. In fact, but this is interesting. That's not what Dijkstra wrote. His letter is this. Dijkstra is very meticulous in keeping a copy of everything he ever wrote and numbering it. So this is Edgar W. Dijkstra, note 250. A case against the go-to statement. That's much more modest. So what's this go-to statement considered harmful? Go-to statement considered harmful is 1960s clickbait. Okay? You'll never believe what happened to my enterprise code when I used a go-to. Yeah, it's one of those. Funnily enough, the person actually responsible was Nicholas Wirth. Nicholas Wirth was the editor of communications to the ACL at the time. Nicholas Wirth is known as not only as a proponent of structured programming, but as the inventor of Pascal. So this is a block structure, all the rest of it. There's only a few people we need to worry about, and that's that. But the concerns remain. A lot of people get absorbed with the idea of structured programming is just about the go-to. There was still a concern in the mid-90s when Taligent wrote this in their guide to designing programs. A go-to completely invalidates the high-level structure of the code. So we're not just talking about local things. It's this idea that we have this beautiful nesting structure, and then these statements cut across it. They disrupt our ability to understand them. They're kind of like a jump lead from one piece of code to another. So let's look at it from a bigger picture point of view. Let's look at it from the perspective of architecture, architectural styles, and paradigms. Bas Clemens and Kasman wrote in Software Architecture and Practice. They characterized, in fact, they were the original people to characterize this. This came out of the Software Engineering Institute at Carnegie Mellon University. They started exploring architectural styles. And they ended up with a name, it's a terrible name, main program and subroutine. Nobody ever calls it that. We all call it procedural programming. But nonetheless, they decided we're going to call it main program and subroutine. So what is the characteristic of the main program and subroutine style and approach to organizing your systems? The goal is to decompose a program into smaller pieces to help achieve modifiability. Well, that doesn't really tell me very much. I mean, honestly, I don't know of any paradigms which don't claim this. Okay? Except perhaps the keep your job paradigm. Okay? It's just like, you know, I'm going to write it this way and they will never get rid of me because nobody will understand it. Okay? Pretty much every paradigm has this as its goal. What differs from one paradigm to the next? From procedural to functional to object-oriented to relational to logic, whatever paradigm we're exploring, they all have this. It is decomposition. We take the big ball of mud, we break it into pieces. It is the philosophy of what each piece represents and the nature of connection that makes one different to the other. That's what's interesting. And the clue is in the next line. A program is decomposed hierarchically. There are our trees again. Excellent. So it kind of looks like this. There you go, main program, subroutine. That's the whole structure. The idea is the philosophy of structured design. Let's move up from the simple block to the whole piece of code. The system as a whole. It is this hierarchical construction. And one of the things that people are not aware of is that in structured design there was actually a philosophy, there is structure to this. It's not just top-down decomposition. It turns out that there is a way of organizing the code that people have often forgotten. What I find interesting about this, from the point of view of this talk, is the terminology. This is the afferent branch, transform branch, the efferent branch. I'll explain what those mean. The only word I need you to concentrate on at the moment is the word branch, because trees have branches. Okay, look, the metaphor runs deep. But what we're actually saying here, this is effectively input, afferent, transform, process, efferent, output. Input, process, output. Input, process, output. There was even a methodology in the 1970s called HIPPO, hierarchical input, process, output. In other words, so there is this idea, again, hierarchy. We've got a structure, there's a linear approach. We're going to take stuff in, we're going to work on it, we're going to do stuff out. Now, the thing is, this isn't very good for event-driven programming. It's not very good for interaction-based programming, which dominate the landscape now. But this is what is interesting about Jackson's work, is when he started revisiting his work, when he started in the 1990s revisiting it, for example, in that book that I showed you, Software Requirements and Specifications, he said there are different ways of framing the problem. Some problems look like input, process, output. They are data flow problems. And if they look like data flow problems, we already have an architecture that fits. And then he explored a number of other problem frames, as he referred to them. Now, what is interesting here is we can change the name, subroutine, we can change it to procedure, we can change it to function. What I find interesting is that a very similar structure exists for functional code. These are decomposed hierarchically, they have a model of composition, and they also work very well for data flow. But their philosophy on local state and a few other things is different, and that's what differentiates things. And this is all beautiful and tree-like. But let's go and look at real code. What does real code look like? And I mean without the go-tos. Okay? It turns out that even what we consider to be good code has slightly different structure. It has reuse. It has fan-in. It has the idea that I'm not going to duplicate that code because it turns out we are doing the same thing. It mixes its levels. It shares code, at least if you're doing it right. Otherwise you're busy copying and pasting. How much did you do this morning? Oh, there's an extra 1,000 lines that I put down. The fact that it bears a striking resemblance to another 1,000 lines in the same code base, don't worry about that. And then, in a true block structured language, you also have recursion, simple recursion and mutual recursion. Notice what we've done is we've stepped outside the tree structure. It's loosely hierarchical, but not totally hierarchical. It has a sort of, kind of, top-downishness, but it's not perfect. And we also have another question. How do you create such a thing? So, this is kind of this is a lovely book. This is there is an anniversary edition. I read this, oh God, when did I read this? 1980, late 80s. Girlfriend, her dad recommended it to me. He was a great guy. I mean, honestly, going out with this girl was great because I got so many recommendations from her dad. But this is a really influential book. I dipped into this one from about the mid-80s onwards, and I read it back to front, which is a really strange way of reading it, middle out and front to back. It's really good stuff. But in it, Douglas Hofstadter talks about systems, he talks about the problems of hierarchy, and he introduces a rather useful word. A program which has such a structure in which there is no single highest level is called a heterarchy, as distinguished from a hierarchy. What we find is that as we descend into certain code bases, we find they lose hierarchy, they become heterarchical. They may have had a clear root, but then when we go beyond that, we lose the tree structure. They start off tree-like, but they become very tangled. That's not necessarily a problem. There's lots of different kinds of tangling. You can have a messy heterarchy, just as you can have a beautiful hierarchy filled with duplicate code, therefore not that beautiful. So the point here is I'm not saying it's necessarily a bad thing or a good thing, but we are moving away from the idea that I might have a root description of the system that breaks down into a nice hierarchy, but I should be prepared for the fact that that hierarchical view, that decomposition, should not go all the way. I may find that I want to give up that style of description. And then we have this lovely observation from Alan Perlis, who's the first recipient of the Turing Award. Everything should be built top down except first time. Now, what's he saying here? What he's saying here is that, how do you know? Top down, it's lovely, it's a wonderful story to tell. First of all, we take the root of the system. What is its purpose? Then we decompose the root into sub-purposes, and then we decompose those. And that's beautiful. It's also complete fiction. Perhaps you are perfect, but I'm going to go with the fact that maybe you're human. So there is a problem here. And what he's saying is accept the first time. What he's saying is, I found this profoundly influential. It wasn't his original quote, it wasn't his quote that influenced me, but it was a very similar quote a number of years ago, which was that it's top-down is a great way to describe a system, but it may not be the best way to build it. Yeah? In other words, once I have built it, I have far greater knowledge than I did when I started. To build something top-down perfectly the first time assumes you have perfect knowledge, but we work with incomplete knowledge. That's not going to happen. But when I come to describe the system to you, as long as I've been good with my refactoring practices, then I should have hierarchical, loosely hierarchical structure that makes sense. And I'm not going to give you I'm not going to give you the worst parts of the story. I'm going to give you the best parts of the story. But this does also raise the question of how do we build a system? Let's try writing some tests. Let's do it very much from the business domain's perspective. I don't know, maybe we should use SpecFlow. Does that sound good? You know, it's not a bad idea. There you go. I've written some scenarios. This is fantastic. This is behavior. What I've done is I've focused on the behavior. I've described the desired behavior. And now I'm going to fulfill it with code. Brilliant. Big block of code. We know there's going to be some refactoring involved. I hope. But in the failure mode, what happens in the failure mode? The failure mode is we've got this big block of code, we've got some big controller, and we've lost our domain. Now, the domain is kind of implied, but it's kind of lost in flags and variables and stuff like that. We've got a lot of control stuff. But it passes the test. Be very careful who you show this to, because that's brilliant. Can you do the next one? Then the next one. And then we might want to so what we've got, and this is a very common problem you can get if you just do story-driven development, you can end up saying, well, we're going to do some refactoring, that's fine, but we're going to do it within each story. And you end up with these little silos where you have these beautiful little trees, but they're all hanging off very specific scenarios. What we've missed is the fact that our tree-level description has gone far too deep, and somewhere in there, our domain model is being duplicated. But we haven't really thought of it as a model, we've just driven it from a very procedural approach. And we don't really want it like this. If anything, the next step should have been recognize commonality, then push further. Then we end up with this. And so we've got this idea of being very careful with the steps that we take. We cannot just simply impose a tree, we have to be very careful and say, well, now that I've written this, what's my next step? Let me seek commonality. Let me actually look. Have I learned something new about the domain? Have I expressed my domain clearly? And this becomes the next question. And it ends up sometimes looking, bits of it look hierarchical, but bits of it don't. And so there's this idea of being very careful not to end up, if you ever end up with trees hanging off controllers, then you know you have a bit of a problem there. If you just end up with controllers and no trees, you have an even worse problem. You have a very large piece of code. We also have the problem that this is not necessarily a natural thinking model. Remember, in code there is no gravity. Okay. Well, actually, no, there is. If you ever come across a class that's 10,000 lines long, that has its own field of gravity. It pulls all the other code towards it like a black hole. But the general sense is up is an abstraction. We must always remember when we do models that there is no natural up. Okay, this is quite an important one because we're human beings. We have a sense of orientation. When you model things out on a whiteboard or with stickies, without realizing it, or possibly realizing it, there is a significance to how you arrange things. There is a spatial significance. Human beings give meaning to space. Okay? The problem is that that's not reflected in a software system. The software system doesn't have a natural up or down. When we talk about layered architectures, we think in terms of ups and downs, or if we're thinking hexagonal architectures, insides and outsides. Again, code doesn't work like that. That's not what it looks like. So the point is that we are projecting an idea that makes it convenient for humans. Yeah, we must remember that. But it's a learnt skill, which is why beginners struggle with this. Things that become natural are, with experience are not necessarily natural to start with, which is why we end up with spaghetti models and spaghetti code. So I'm going to dig a little bit further into this, because one of the things I quite like is programming history and the history of software development. What I find interesting is that in the structured programming book, a lot of people thought structured programming was just about organizing your control flow and not using GoTo. But it turns out that there is a section of the whole book called hierarchical program structures, and it is not talking about what we've been talking about so far. It says a procedure which is capable of giving rise to block instances which survive its call will be known as a class, and the instances will be known as objects of that class. Now this is kind of interesting, because what we're saying, what if I call an action? Here's the idea: if a procedure represents an action and it has local state, what if I call an action? Normally you'd think when you finish the action, you throw away the state. You pop the frame off the stack. What they're saying here is you've got this state and you can embed behavior inside it. What happens if you give it to somebody else? It's got procedures and variables. That's an object. Indeed it is. This is exactly where object orientation came from. This is the description of Simula 67, which basically extended, so classes are basically named blocks that survive. As I said, a call of a class generates a new object of that class. And then they introduce this crazy idea, class concatenation. These days you call it inheritance. Concatenation is an operation defined between two classes A and B and results in formation of a new class or block. So what you're able to do is concatenate. You can consist in merging of the attributes of components and comparison of their actions. So the composition of their actions. So this is interesting because what you're able to do is take something and then extend it. Now, the instinct that everybody has is like, and this was as people started getting into object orientation at the beginning of the 1990s, the big hype was you can reuse code. I can take a piece of code somebody else has written and then just adapt it and replace the bits that I want. And sometimes people say, well, later on people came around and said, oh, you shouldn't do that, you should organize it according to classification. Use this as a taxonomy organization. This is classify. Yeah, that's a really new idea. Let's have a look at what they said back in 1972. Concept hierarchies. The construction principle involved is best called abstraction. We concentrate on features common to many phenomena, and we abstract away features too far removed from the conceptual level at which we are working. In other words, their guidance for how do you use this language construct is classification, it's taxonomy, it's hierarchy, class hierarchy. So in other words, all of this idea of substitutability, all this kind of, that's always been there. It's just people ignored it. Okay, so let's return to a kind of a simple domain model. No hierarchy yet. This is very tangled. Why? Because the real world is a mess. That's why. So be very careful to not impose hierarchies where there aren't any in the real world. Be very careful. The real world is a mess. It's filled with two-way relationships. And I'm just going to take this a little fragment of a book lending library problem. Now, the book lending library, as a case study example, has been used for decades. I had an interesting experience 20 years ago with a colleague, and he said, oh, Kevin, you're still using the book lending library thing. And I said, yeah, I find it very rich. I'm able to do testing with it. I'm able to do domain modeling. I'm able to, there's a lot that I can get pretty much any topic of conversation in software, scenario modeling, use cases, user story, I can do it all. It's great. You can do the whole structure. I can take agile approaches through it. And he said, oh, no, I've given up using the library. These days I'm much more up to date. I use video rental stores. Yeah, I'm still here. I actually had to explain to my kids what a video rental store was. They were, the younger one who's now 12 could not remember videos. The 16-year-old remembers videos, just. The 12-year-old doesn't remember videos, but was shocked to discover that you would go to places and rent videos that other people had touched. It's just like, whoa, they prefer the clean electrons that you get from Netflix. So, what we've got here is we've got something that's got some cycles in it, okay? Member depends on loan, loan depends on member. So a member has a loan is against a copy of a book copy is against the loan, it's against the member. Okay. So we might say, well, perhaps I need to disentangle this a little bit. So let's introduce some interfaces. Now the problem is that programmers come at interfaces and they go, oh, right, okay. These are like abstract classes and they mess about with that. They instantly put those in. So far this is good. A member implements this, or inherits from this, a book copy inherits from. The question here is, what is the name of this? What do we call these things? Is there any .NET programmers in here? Okay, what are you going to tell me? I came, I saw, I conquered. Yeah. I remember, I book copy. Yeah. Now, the problem here is we haven't really explored the domain here. We've actually deprived ourselves of an opportunity. And this is the important thing. All we have done is avoided name collision. And that was not the goal of this. The goal here was to find the core concept. Loan relates to something, it's a connection between two concepts. What are the names that are involved in that concept? And perhaps when we arrive at the domain, we have weak understanding. We go, yeah, we've got member and book copy. That's fine, that's our first draft. And so maybe we don't have better names. But the problem is we're saying, well, how do I get a thing that's, well, how do I extract an interface? I'm thinking from a programmer's level. I'm not really working very deeply. And the problem here is if you look at the names, never underestimate the power of names and the attraction of trees. Trees are very attractive. And granted, this is not a very big tree, but here is a tree. And there's another tree. We are drawn, the names suggest that this is the way of looking at it. So in other words, what we're doing is we are seeing a vertical alignment. We are thinking there is this hierarchy and this hierarchy. Now, there might be a few people in here who touch the code and are thinking quite smugly, oh, I'm not one of those people who puts I in front. No. I put impl afterwards. You are just as guilty. Okay? I don't care if it's a prefix or a suffix, it's an affix. The point here is, I'm not wild about these, but the real thing here in both cases is we have deprived ourselves of an opportunity to name better. Find the names, find the role that is represented. Then you can put your I's and impls and all the rest of it back in again. But the thing is, what is it? What really is it? And if we look more closely, we realize that we're looking at the relationship wrong. It's not a vertical, it's not tree-oriented. What we have in the domain is there is a relationship between loan. A loan is a description, it is a binding. It describes a relationship. Here is something that describes a relationship between two parties, two roles. This is the way to look at it. Okay, not that, it's this. And if we start saying, well, what does the loan want from a member? Does it need its address? No. Does it need the name? No. It turns out that most of the stuff that characterize membership are completely irrelevant. Does the loan care about the book title? Does it care about the other? No. It turns out most of the stuff that we characterize a book copy by are irrelevant. We need to identify the role. The role in this case, this is a borrower. A member is a borrower. Now, if it makes you feel more comfortable to put impl and I back, you do that. You've done the hard work now. You've established what is the nature of the relationship, the real nature. And what we discovered here, just by pausing a little bit and exploring, is, and breaking away from the tree view, which is very attractive, is realizing that you can now take these away. This is the essence of a library. It's about the borrowing relationship. Now, there is a slight problem, is loanable is not necessarily an English word, and we don't, if you talk to a librarian, they may call it a loan item. I don't care, you have to go and talk to the librarian. I actually joined the local library recently and did have a conversation with the librarian, but I didn't say, guess what, I'm a software developer and I'd like to find out about your domain. But I didn't establish properly what they call that. Okay, so this is still up for grabs. Okay, so the point here is that the tree view was distracting. The names encourage the tree view, but that's not what we wanted to do. We need to pull back from that. From an implementation perspective, we're also drawn to these things. So here is a structure of code that a project that I was mentoring a number of years ago in Munich had this structure. I saw a very similar structure again just outside London in Surrey a few years later, but the one in Munich was particularly interesting because they were developing pretty much the full system. They were developing the middleware and they were developing the application domain stuff. And the way that they had gone about it is that they had basically said we're going to have core infrastructure, then we're going to have higher level services, and then we're going to have the domain. And the way they had done it is they had used inheritance to aggregate these capabilities. Now the problem here is that although this is, this is kind of nice, it's one big tree, very big tree. Tallest tree in the world, 116 meters high. It's in California. And nobody knows where it is except for the Forestry Commission, because they don't want people to know which one it is. Because it's not just selfies that people take, it's just like, yeah, I'm going to take that mad chainsaw go-to and just cut that tree down, yeah? So, now, the problem here is that this is a very programmer way of looking at it. What we've ended up doing is we've accumulated behavior. We've treated inheritance like a toolkit. You inherit everything and then you add things. We've just gone for the addition approach. The problem here is that this is insanely difficult to test. Because, again, the tree view, what people often are drawn to is they focus on this relationship. The point here is that most of the behavior of a system is to do the other relationships, object to object, entity to entity. So we kind of leave these out, and this looks really tough. The problem is you've now pulled down, if you're down in this application class that is busy focused on the domain, you've got all of the dependencies of everything above you, which is actually quite heavy. And it's insanely difficult to test, and that's exactly the experience the developers were having. So it's nice that we can draw some layering here, but this is not really how developers are experiencing it. Particularly, and they did have a divide, application developers and infrastructure developers. And the infrastructure developers didn't notice the dependency problems because they never saw this part of the tree. Yeah? Whereas, if you're at the bottom, it's kind of like a human pyramid. If you're on the ground, you notice the weight a lot more than the people up the top, okay? And that's exactly what the application programmers are experiencing. So I made myself immensely unpopular by saying we need to change this. Now, what was interesting is that I wasn't really there to re-architect it, or rather, I didn't re-architect it. I just kind of it's like a domino kind of thing. I kind of pushed it and then they re-architected it. That was not my goal. My goal was simply there to review the tests. On that visit, I did some domain modeling with them, but that particular visit where I discovered the problem, it was because I was reviewing their tests. So you start with the test, and you look at the test, and you go, wow, this is really hard. In fact, no, the first test was the best test. Sitting there with the developer, looking at the screen. And he's walking me through the test, and I'm just thinking, this is Eclipse, and I'm going, isn't that colour that the code is in, isn't that the same as the colour of comments? And he said, yes. This is all commented out. So this isn't actually code. No. This is the test I would like to write, but because of the infrastructure, I can't write it. And I would like to write it, and I'd like you to review what I would like to write. But it's just like, no, this is a work of fiction. It's not real. It will never run. And so this became, and so as I reviewed around, other people had come up with other ingenious things. So I found one person who cleverly wrapped all of the infrastructure and all of this. And that's the whole point. You're not supposed to... Wrapping is something you do with old code. This code was so fresh, you could still smell the ink off it, okay? This code was fresh, and they're already wrapping it. That's a bad problem. So, in other words, we're getting all this feedback from different developers. This is impossible to work with. So, ultimately, I made myself unpopular by saying, perhaps we should reorganize this. And this is what we ended up with. We still have the layering, but notice there is a fundamental difference here. This was not anchored in the domain. This was squashing the domain. It was giving a weighted dependency. It was infrastructure oriented because infrastructure is the first thing you see at the root of the tree. Now, instead of having one tree, what we've ended up with is a nice forest. Okay? We still have trees, these trees, those trees, and those trees. We have infrastructure trees, service trees, and domain trees. But what we now have is a decoupling. Our differences between concept and realization, whereas the previous one tried to blur them all into one. Now, I can test this without having all of that, because these are just concepts. I can now mock them out and do all the rest of it. So I have even better layering here, and this is domain centers in the way that the previous one was not. So we took the large tree and we made smaller trees out of it. So here's the point. When we talk about the stack, we often focus very much, when people talk about being full stack developers, they focus very much on the technology. And in fact, they focus on a tiny part of the stack as well. Whenever I talk to full stack developers, it's just like, yeah, they kind of stop at the database. It's just that. My background is in embedded development and real-time development. So I'm sitting there going, yeah, the database, that's up there. It's not down there, it's up there. So whenever you ask a full stack developer, what's your device driver experience? They can't look at you blankly. I know what the full stack looks like. But that's the downward view. The full stack goes out into the world. The full stack starts from outside. That's the fullest stack you can get. What's the world outside look like? And it turns out that's got all kinds of shapes and questions that we want to ask. So, this is a slightly unusual book cover. Design After Modernism. It's a book on postmodern design. It's edited by John Thacker. It contains a number of different essays in it. This book was published, I think, in the early 1980s. So I managed to get my hands on a second-hand copy. The main reason I wanted it, there are some fine articles in it, but the main reason I wanted it was for this piece of writing. The City is Not a Tree, which is where I take the title of this talk from, by Christopher Alexander. This was actually published in 1965. And until recently, it was not available as a separate piece of writing, so which is why I got this. I have since discovered that it's been published, and I can get it from amazon.co.uk for £100, which is like, that's kind of expensive for what's quite slim volume. I've discovered I can get it for $20 from the US, except for the fact they won't ship it over the Atlantic. So I've got a friend sending that even as we speak, it should in theory be somewhere over Greenland right now. However, this is where I read this originally. And Christopher Alexander, if you're not familiar with it, he's the guy who came up with Timeless Way of Building. What's that? It's a book on patents. He is Mr. Patents. He and his colleagues in the 1970s originated the idea of patents, which then went on to influence software development itself. And often people will think of patents as being introduced in the 1990s. Actually, the first patents paper was in 1987. And 1987, and it was co-authored by Kent Beck and Ward Cunningham. Kent Beck, the originator of XP and JUnit. Ward Cunningham, I don't know, he didn't do much except invent Wiki. So, whenever I talk to my kids about stuff, do you know anybody famous? The only person they're ever impressed with, is I can say, I've met Neil Gaiman and I know the guy who invented the Wiki. Oh, that's pretty cool. And they introduced this in 1987 because they'd read Christopher Alexander's work and said, this is really interesting. This is an interesting way of thinking about architecture and building architecture and structure and organizing your knowledge. And they said, I wonder if this would work for software. So they kind of started the whole thing. Anyway, back to the city is not a tree. What was Alexander saying in this? He was saying, the tree of my title is not a green tree with leaves. We're good with that. We're in software. We know this is good. It is not the name of. It is the name of an abstract structure. This is sounding great. I shall contrast it with another more complex abstract structure called a semi-lattice. Okay, so what we're talking about here is really a graph of some kind. Both the tree and the semi-lattice are ways of thinking about how a large collection of many small systems go to make up a large and complex system. So he's not just simply talking. What I find interesting about his writing is that although he's anchored in architecture, building architecture and the built environment, he often sort of steps outside to talk about other aspects, other systems of thinking in the world. So, there you go, this is a tree. Perhaps it's the tree of an organisation. Oh, we love organisational diagrams that look like this. Okay. Organisations love them, they're organograms. Okay. There's the boss, here are the departments, it all looks brilliant. That's not how business gets done. That is not how people develop. That is not how organisations actually work. It is a beautiful fiction, but this is how people work. And that's a little bit messier. People don't like that. They want to impose another order to it. As he says, semi-lattice is potentially a much more complex and subtle structure than a tree. He recognises this. But the point there is, just as Jackson said, don't kill, if you've got a tree, show a tree. The other point here is, if you don't have a tree, don't show it. Okay, don't force something into this strict hierarchy just because it looks a bit tidier. You will eventually hit the friction that comes from that. It is this lack of structural complexity characteristic of trees which is crippling our concepts of the city. What he was criticising, particularly in this paper, was the fact that city structures, if you're trying to design a new city, there's this lovely idea, you go like, city, centre, we'll have residential, it'll be beautifully tree structured and very elegant, and we'll have the main roads doing this. And yeah, it turns out that's not how humans work. Those cities look terrible after a while, unless people are given the opportunity to rezone them and to mess about with them. The reality of today's social structures is thick with overlap. This is how people live. It is also how organisations structure. We do not work in a strict hierarchy. The systems of friends and acquaintances form a semi-lattice, not a tree. That's how you end up with these small world coincidences. Hey, you'll never guess who I met. Friend of a cousin, all this kind of thing. It's like, hey, we both know this person. Who knew? That's because it's not a tree. Yeah? So, in the tree view, in the hierarchical view, there are two fundamental ways you can organise things. You can decompose, you can nest, this is your hierarchy, and so on. Perhaps this is your organisation. Perhaps you've decided these are the concepts in your domain. This is nice. So one of them is strict nesting, and the other one is no nesting at all. So in other words, it's either inside or it's outside. And it's a very simple way to organise things. The problem is that actually it looks like this. This is, now, this is going to be a bit of a problem because there is a little idea in domain-driven design. We'll say, well, it turns out that people don't use words consistently. Different parts of the business have different language or different suggestions or connotations. When we use a word, we use it to mean this, and those guys use the same word, they use it to mean something else. One of the classic examples, and I remember colliding with this a company, I was just running a training course since the late 1990s, and it's before I was really aware of how to solve this problem, the bounded context approach. But I visited a company that did medical software. The word patient is a nightmare. It's one word, and yet you speak to different people in the medical profession, and it means completely different things. It has different database connotations. And so there is this idea of, we need to understand, are we talking outpatient? Who are we talking about? Okay, and it turns out that for each context there is a slightly different thing. That's great. The problem is that context, when people use this lovely term, bounded context, it makes it look really tidy. It's not. Bounded context is a conflicting context. Bounded context has a boundary, as the name kind of suggests. It's not the stuff that's inside that we need to worry about, it's the edge. Where is the edge? And who do we agree with or disagree with? We negotiate the boundary, and that boundary can change over time as we understand how it works. So perhaps we shouldn't draw them with overlap, we should draw them like this. We've got this set of stuff, and then these interactions. These are the points of communication, but communication also means potential conflict. Now this diagram is taken from a book. It's taken from this book. Christopher Alexander, he seems to be everywhere. Okay? Okay? That was not the original intention of this talk, but it's just like, this is 1964. This book was very influential, Notes on the Synthesis of Form. I'm reckoning that he never said that out loud. That doesn't really, people often refer to it as Notes or just Synthesis of Form. This is my copy. It's got, these days it would be filled with colour and all kinds of possibilities and crazy fonts, but I like the kind of like, there's a raw sense, it's just black. And this was very influential. I really didn't understand how influential it was. When I read it in the 90s, but it was only in the last couple of years I started discovering that it had actually a strong influence on software development and development thinking in the 1960s and 70s. I just want you to remember that diagram. We'll come back to something that looks very similar in a moment. So Alexander says, and he's not just interested in buildings in this book, he's just talking about creation of things. How do we create form? How do we create structure? Whether it's abstract, whether it's social structure, whether it's informational structure, whether it's physical structure, like buildings. And he says, we may therefore picture the process of form making as the action of a series of subsystems, all interlinked. So he recognized we have hierarchy, but we have connection. You cannot separate one from the other. All yet sufficiently free of one another to adjust independently in a feasible amount of time. Now, if you're thinking from a coding perspective, we're talking refactoring here. Okay? But if you're thinking from a people perspective, we are talking about the fact that two different groups of people may actually have slightly different views of a system, slightly different understandings of the business, and yet that is okay. It's all right, as long as we recognise that that is a possibility. That is a possibility, because that's how a system learns. A system of people learns by one group of people discovering knowledge that is different to what they already knew, and perhaps differently to what other people knew. If everybody's tightly coupled, this becomes a problem. If nobody's talking to anybody, this is also a problem. So we need to find something along this continuum. It works because the cycles of correction and recorrection which occur during adaptation are restricted to one subsystem at a time. We localize it. Locality is really important, whether we're talking about teams or whether we're talking about code. It's the same kind of concept. Now remember that diagram I got you to remember? It turns out in the 1960s everybody was drawing bubble diagrams with lights. This is the thing. I read this paper a few years separate from reading the Alexander paper, and it was only this year that I made the connection. This is taken from a paper written in 1968, which with any luck people have at least heard of the idea. The guy responsible for it was Melvin Conway. This is Conway's law. Okay? Turns out everybody in the 60s knew a whole bunch of stuff that we've been busy rediscovering and patting ourselves. Well, aren't we clever? Yeah, it's just like, no. How do committees invent? The basic thesis is that organisations which design systems are constrained to produce designs which are copies of the communication structures of these organisations. He's not saying they are copies of the organisational chart. It's the communication structures. How do people actually communicate? And that often relies on friendships, it relies on geography, and it relies on other structures which are more visible. But he then makes another point. So people often quote this one. People often don't quote the next bit. We have seen that this fact has important implications for the management of system design. A design effort should be organised according to the need for communication. What does that mean in practice? It means if you've got your product people in a different building, and you've got your developers over there, and you've got your system testers over there, this is a really bad way of doing it. Yeah? This is, the idea is, who needs to talk to whom about what? You kind of put them together. This is a crazy idea that we reinvented a few years later and called agile development. Or just sit together or whatever. The whole point here is that he is actually saying, if you want to create a technical artifact, software is a socio-technical thing. It's not just a technical thing. And honestly, I got into software development because I like code. It's as simple as that. And then I've spent years discovering, oh, damn those people. So I've had to learn about people, and it turns out people aren't quite so bad. But this is the point, that it makes you realise that there is a deep reflection here. Which again is frustrating, because people like to do things in simple sequences. Because we have hierarchies and we have sequences. This is the way that people think. And so we end up with this kind of force coming from Conway, as it were. And it is definitely, we talked about this. I co-authored a couple of patents books a few years ago, and we spent a bit of time in Poser 5 talking about Conway's law. And we sort of said in referring to this as a law, the appeal is to a force that will shape the system, much as a physical law, rather than as a rule that should be followed, as with the laws of a community or a state. This is quite important because sometimes I get people going like, oh, we shouldn't follow Conway's law. Yeah, good luck with that. It's a bit like me waking up in the morning going like, you know what, gravity? I'm not going to follow that law. I'm through with gravity, it just makes me tired. Okay, that's not how it works. Okay, the idea here, in this sense, it is not a law that can be broken. The force is always there, only one that can be counterbalanced by other forces. So tomorrow night, I am taking a flight on an A320. Is it A320 or is it A321? I don't know. Yeah, A321. Sorry, my kids get bored when I start going into airplanes, but okay, it's an A321 because the back seat is row 30, and that's an A321. 320 stops at row 26. Yeah. I never remember anything useful, but you know, I can tell you the best I can tell you the best seats on a British Airways Airbus. Right. The point there is that tomorrow evening, I am not going to defy the law of gravity. I mean, that'd be quite cool, but sadly, I won't be on the news defying the law of gravity. I'll just be on an aircraft. And it turns out that aircraft do this by a sense of balance. And this is important because there is a model, what's known as the four-force model for flight. Basically, these are not independent, they are interdependent, but the way that people look at it is like, there's your force that you don't get to really change that much. Okay? Thrust takes you forward. If you've got the right shape of craft, that will give you lift, but on the other hand, nothing is for free, there's friction, there's drag. Okay, so these are the balances. This is what's going, and this careful balance will, this is what the pilot negotiates. This is what the designers of the aircraft negotiate. That's what gives you that. Now, obviously I'm messing about a little bit here, but let's just try this with software development. Let's just try this for a moment. There you go. Now, of course, it's not exactly that. You can mess about and move things around, but what I want to try and do is give you the sense that these are interdependent. There is a relationship here. Okay? So we've got this idea of Conway drags you down. Now, actually, it turns out that I can reshape. I can't reshape gravity, but I can reshape. It's like just as I can reshape the load on an aircraft, I can make it lighter. The idea here is we can shape the communication structures. But once you've got those communication structures, you are dependent on that for how the information flows and how people organize their code. Your development practice is what's going to lift you. That's the thing that you're after. Design effort pushes you forward. Debt holds you back. Okay? So this is the kind of way to think about these things. Honestly, don't take this too literally. You can sit there after a few drinks and come up with your own reinterpretation. Feel free to do that, okay? There are 4 arrows, fill in the gaps. But ultimately what we're saying here is that there is no simple linear approach. We're not saying design forward, analyze your domain, design against your analysis, implement and then write tests or anything like that. It doesn't work like that. It's a lot more messy. It's not sequenced. It doesn't fit within sequences of nested groups. The very process of how humans work is a lot less tidy. And sticking with the patterns theme, we go back to the early 1990s. There's a collection of patterns. There's a number of different books, Pattern Languages of Program Design. I like this particular one. We've already met Ward Cunningham. The early 90s, he wrote a pattern language, a set of interlinked patterns, competitive development, called episodes. I was very influenced by this back then. There were a number of things that I found very influential from 2 or 3 different sources. This was one of them. And Ward documented this, and here's a diagram of how he considers the practices. And this is kind of interesting because if you look, what he's doing is each one of these is a pattern. It's a practice. It defines a practice. Some of these are to do with the product folks, product initiative, marketing walkthrough. Some of these are very clearly focused on the mechanics, test fixture. Okay? He doesn't document all of these in words. Some of these are documented in words, but he shows you the map of the whole thing. Notice that his arrangement of connections of the patterns is non-tree-like. This influenced Kent Beck's extreme programming and the interconnection between the practices in XP. this is also, we find there are a number of ideas here that are very, here's pair programming, where's pair programming facilities, pair programming episode, work queue. You know this is backlog. Okay? This is the origin story. This is one of the key influences. It is also messy, because each one of these patterns relates to other patterns, and if you're doing this, it sets the context for another pattern. You might want to be doing this. It's one of the reasons why Ward invented the wiki. He invented the wiki because he wanted a non-hierarchical way of documenting it. He wanted to be able to document patterns and their connections. That's why the wiki exists, because it is a network that is a semi-lattice. It is not a tree structure. Okay? So standard outline document from Word is a tree structure. But he was saying that's not how these practices are organized. Practices reinforce, and you flow from one to maybe another, and it comes back at you, and so on. So, one of the things we learned, given we're talking about architecture, and hey, guess what? Christmas is coming. Looking for a book? Honestly, I recommend this one. 101 Things I Learned in Architecture School. I've recommended this, by Matthew Frederick, I recommended this so many times that every now and then I get people either directly tweeting at me or coming up to me at conferences, hey, I bought that book, it's great. It's one of those books that makes you look smart. You don't actually have to read it, it's just that people will look at that. They see it on your desk, it's got beautiful illustrations, and it's got 101 practices, and opposite pages a diagram, and then there's some text. And it's very elegantly laid out, and people look at that and go, whoa, not just a software developer, they're sophisticated, cultured, and smart. I like this person. I kind of wish I was on commission for this. So a friend of mine who works at Spotify, he kind of said he eventually ended up getting 2 copies because his wife stole his copy off him. Because his wife is actually an architect. not one of these pretend software architects. No, she's actually really a building architect. And she said, what are you doing with this book? Oh, this is really good. I said, that's my copy. Okay, we'll get another one. So there's a lot of good stuff in here. Because what he's talking about here is building systems. He's talking about the work of design, the work of creation, the work of structure. And it turns out about 50% of this stuff is applicable no matter what you're doing. And the observation that we see is that our attempts to order things, whether we're structuring our teams, whether we are trying to organize our time, and we're going to do this, we can do all the analysis, then we can do all the design. As you're saying, properly gaining control of the design process tends to feel like one's losing control of the design process. What you're doing is you're working at a much more meta level. The idea is that actually what you're doing is you are working with a set of strategies that loosely swarm around, and every time you learn something new, that can push you in a new direction. So what you're doing is you're not saying we don't know, you're not just saying we don't know how to do this, or we're not going to tell you, which is sometimes how people respond. They say, those agile developers, they don't tell us what they're going to do. No, what you're doing is you're saying, we don't know, but we know how to find out. That's a very different kind of proposition. We don't yet know the shape of the domain, but we can find out. We've got some ideas, and then we're going to try things, build things, and we're going to interact with the knowledge that we get from that. And it's a lot sloppier, but it is surprisingly effective. So I'm going to leave the last word to Christopher Alexander. He said, in simplicity of structure, the tree is comparable to the compulsive desire for neatness and order that insists the candlesticks on a mantelpiece be perfectly straight and perfectly symmetrical about the centre. That is fine for your mantelpiece, but when you start scaling that beyond your mantelpiece, it says, look, the semi-lattice, by comparison, is the structure of a complex fabric. Our software systems are a complex fabric. It is the structure of living things, of great paintings and symphonies, which I think is kind of a nice note to end on. You thought you were just working with code and software. It's the stuff of symphonies, that's what you're working with. Thank you very much. Yeah, 1 or 2 questions? Thoughts, reflections? I know. It's the middle of the week and, it's hump day. And, oh, God, honestly, really, Kevin? You have to talk about all this kind of like philosophical stuff? I just want some easy tips to take into work tomorrow. Sorry.
Well, we can stay for discussions, I guess.
Yeah. So, thoughts, reflections? Yes.
Are there any other useful structures either in reflecting the real estate or just thinking about it?
I think there are, and I've kind of restricted it, but if you like, there are always useful structures. You know, there are cyclic structures, there are, you know, you basically just, if you pick up enough books, they will show you shapes, but they may not make a point about the shape. And what I find interesting is this idea of looking at these things from that point of view. As it says, the structure of living things, what do living things look like? That's kind of interesting. Living things have a very different kind of structure. They have redundancy, they have a bit of mess, but they are also surprisingly tolerant. If anybody's working with machine learning, you'll discover very quickly that that whole notion, why do we like trees? Because they are understandable. What is the problem with machine learning? It's completely not understandable. Okay, but it's non-hierarchical as well. So we've got this kind of trade-off. Yeah. So all I can say is just look around for structures. Mathematicians seem to delight in this kind of stuff. But sometimes you may also find, just simply looking at a diagram, an illustration of something, it's just that gives you a different idea. I find that when people draw things that I find familiar, when they draw them differently, so for example, when we draw layering, one way of drawing layering is top to bottom. That gives us one mental model, but we can also have a more onion ring approach, which is inside-outside rather than up and down. And just by redrawing it, it suddenly changes the way that I might perceive a system. And indeed, when I made that recognition in one particular system, I ended up flipping all the interfaces inside out. And that simplified things like testing and so on. So the idea is go around and look at interesting geometries, just even if it's just random. Yeah, you know, if you've got kids, they've got books with books with pictures. Yeah. Those are great, but you know, you can say you can now claim books with pictures as a business expense. But the idea is use these as inspiration, because these images, we are human beings, live in the physical world, and even if you don't consider yourself a visual person, you are a visual person. It's one of your dominant senses. You respond to that. So sometimes you just need a little more input. Yeah, so just look around. Oh, if you draw as well, that's quite good. That's in Andy Hunt's book on refactoring your wetware. He talks a lot about this kind of stuff. Drawing makes you observe things. Any other thoughts and reflections? I know I've given it's even worse. You wanted useful tips, and I've given you art and stuff. But yeah. Yes.
I just got a note or comment on the role-based interfaces. That's also helpful because then you can have multiple different roles, different interfaces.
Yes, exactly. And that, what is interesting is that this is not new information, but it doesn't get emphasized. It's not as visible. And sometimes because we are visibly oriented, the thing is that, oh, tree. Whereas role-based stuff, if you go back to the precursors of UML, like OMT, that was 1990, there was a lesser known UML-based method in the late 90s called catalysis, and that had a really strong emphasis on role decoupling and looking at roles. So in other words, all of what's interesting, and you go back to Rebecca Wersbrock, and responsibility-driven design was all about role-based approaches. So these ideas have been around. We just need to be a little more aware, because we now realise, oh, okay, actually, one thing can play multiple roles. Mock objects. There is a paper from 2004 by the people that invented mock objects called Mock Roles, Not Objects. They say at the beginning of the paper, mock objects are a misnomer. We should have called them mock roles. Because they said what's happening is people are going out and saying, hey, look, there's a big database, let's mock it. No. That's painful and it's awkward. The whole purpose, they said, was to discover the roles. I am in a given scenario, I am looking at this thing, what role is it to me? I don't care that you're a member, you're a borrower. That's the most important thing. It's that subset of interface. I'm not going to mock the whole the member interface. It's that. So they used it as part of a discovery mechanism. That was their intention. So mock roles, not objects. Google that, it'll take you to the jmock.org site. Right, I've given you plenty to read. I hope that's been useful. Thank you very much. Oh, I'm not concise at the moment. I'll see what's what.
I have a quick question.
Yes.
Try to phrase it understandably. Much of what is showed is about visual structures.
Yes.
What we see and how we perceive the world.
Yes.
Have you tried talking to blind programmers?
No, that's a really good one. Actually, I did know a blind programmer, and I was interested to discuss with him about what he saw, but I did not have any more interaction beyond that. But yeah, there's a really interesting point there about relationship. But again, I think the hierarchical model still works because it's still physical. I can relate it. In other words, if I go back to the idea of nesting things within...
Maybe we're being restricted by our vision.
It's strongly visual, but it also works. It works from a touch point of view as well. But I don't know enough about that. But no, that's a really good line of questioning. Yeah.
Can you sign this copy?
I certainly can. Do you have a pen that works?
I didn't bring
I
mine.
hope so.
Right.
What are you doing here?
What's the date? The 21st. Let's put that one.
Bought this thing at the last craft.
Oops, let's not lose that.
I actually bought this from Amazon.
And it's the 21st. Okay, 21st.
Why didn't you bring it?
Okay.
Thank you very much.
And keep that. I don't want another pen. I've got too many.
So, first of all,